What is the best possible basketball team? Today we'll make a program that analyzes all of basketball history to construct a mathematically perfect team which would put even the US Olympic squad to shame, and all that while staying realistic. We don't want the program to just pick 12 copies of prime LeBron James, as fun as that would be to watch. So here are the rules. Only one of each player, the total salary of all players must be under the NBA salary cap, and the team must have exactly 12 players. To find the best possible team with those restrictions, we will use linear programming. But before applying that to basketball, I'll explain it with a simpler example. Imagine you run a lemonade stand. You have enough ingredients to make up to 7 glasses of lemonade and to bake up to 5 cookies. But the problem is you only have enough time to make 9 items in total. These limits define your feasible combinations. For example, this corresponds to 3 cookies and 4 lemonades, which we can make, but something like 7 of each wouldn't be possible. So how many of each item should you make to maximize profit? If a cookie earns you $3 and lemonade earns you $1, you can draw a line of equal profit choices. 3 lemonades are worth the same as 1 cookie. Now you just slide that line up until it just barely touches the feasible region, and that touching point is where profit is maximized. In this simple example, the best option is to make 5 cookies and 4 glasses of lemonade, but we can just keep adding restrictions, and as long as all of them are straight lines, the best solution is guaranteed to be in one of the sharp corners of the remaining set. Computers can find this corner really quickly by starting from 0, 0 and moving to the next corner if it gives a better solution. You keep doing that for as long as possible and you're guaranteed to find the best possible combination. So instead of checking all these combinations, we just have to visit a few corners to find the best solution. And as you can imagine, when you expand your business and start offering more unique products, solving the linear program becomes very profitable. Now, imagine if we replace the cookie with LeBron James, the lemonade with Steph Curry, and let's add a third player, say Kevin Durant. For each player, we can either put him in our team or not, making this the feasible region. Now we'll add the restriction that at most 2 players can be chosen, leaving us with these possibilities. Instead of profit, our goal will be to maximize points per game. For now. We will start with no players in our team, and for the first step we can pick any one of the 3 players. Let's say we pick LeBron, which is the same as moving upwards. Now we check the neighboring corner and see that adding Curry to our team improves the team's points per game. However, once we check the neighbors again, we see that ditching LeBron for Durant actually gives a better solution. The solution may seem obvious for just 3 players, but what if we just keep adding more and more of them? Past 3 dimensions, it becomes hard to visualize, so let's write it down. For each player, we'll create a variable that is 1 if the player is picked and 0 if he's not. Using this, we can add the restriction LeBron plus Curry plus Durant equals to 2, meaning we must pick exactly 2 of the 3 players to our team. And our goal becomes to maximize LeBron times LeBron's points per game, plus the same for the other 2 players. When written like this, we can just keep adding players and the underlying problem stays the same. Now we will switch the roster rule to exactly 12 players, and we add a salary constraint. The sum of the chosen players' salaries must stay under the NBA salary cap, which was about $140 million last season. This means that we cannot just pick the 12 best players in the world, which makes sense since their salaries would be too much for a single team to pay. For now, we'll focus on the 2024-25 NBA season, but later on we'll collect every single player from the history of the NBA to make the all-time best possible team. So the next step is simple. Collect last season's player data and feed it into the program. The only problem is that there are over 500 players, but we can trim this down a lot to keep only meaningful candidates and make the program run faster. First, I'll get rid of all players that played less than 20 games, since that is the minimum for the data to have any real value. I will also employ a domination system. Player A dominates player B if A has a lower salary but scores more points per game. This means we can always replace B with A and the team is guaranteed to get better. If B is dominated by 12 or more players from the list, we can make a full team of players who are definitely better than him. So there is no way for player B to end up in our optimal team and we can just delete him from our list. These 2 steps leave me with 98 serious contenders, which makes the search fast and focused. Running the linear program now returns a perfect team. On paper. It also exposes three major problems with our current approach. First, almost everyone on the team shoots a lot of shots, but there's still only one ball, so you can't just stack everyone's points like Lego bricks. Second, the total playing time adds up to around 400 minutes, and an NBA game only has 240 player minutes to spread across the whole team, so that rotation simply can't exist. Finally, points scored is only one side of basketball. Scoring 180 points doesn't mean anything if the other team scores 200. So we need to first find a new metric to maximize, which will lead to actually winning basketball games, and second, redistribute the minutes played such that it reflects a realistic basketball team. So yeah, making a perfect team is pretty tough, but making an app doesn't have to be, thanks to today's sponsor, Lovable. Lovable lets anyone turn ideas into working apps just by describing what you want. You don't need coding experience, just type your idea in plain English and Lovable turns it into reality. When I was writing this program, I actually used Lovable to make a quick basketball roster tester. From just a single prompt, it created a full app that let me try out different teams and automatically summed up the total points, minutes, and salary. That tool saved me hours, and I honestly couldn't believe Lovable built all that functionality in under a minute from just one prompt. Whether it's a startup concept, a side project, or just something fun you've always wanted to build, Lovable takes you from idea to live product almost instantly. So if you've been sitting on an idea, now's the time to build it. Go to lovable.dev and use my code DevoteYT20 for 20% off your first premium plan. Or just click the link in the description and join millions already using Lovable to create their dream app. Thanks again to Lovable for sponsoring this video. For the first goal, I could have chosen any one of the hundreds of advanced stats, but I decided to go with value over replacement player, or VORP, which measures how much worse would the team get if we replace the player with a minimum salary bench player. VORP is very useful because we can use it to estimate the wins of the team across a full 82-game season by adding up the VORP of each player, multiplying it by 2.7, and adding 15. Applying this formula to the Los Angeles Lakers last season would have predicted them to win 47 games, and in reality they won 50, so it's a pretty accurate prediction. The best way to think of VORP is as a wins added metric. If we can maximize that, we will essentially maximize how good our team is at winning basketball games. So let's replace points per game with VORP in the linear program. And I'll also add some position limitations so that we must have at least one player of each role and a maximum of 3. Finally, the NBA salary cap is not really a hard limit, but the further above you go, the more limitations are put on your team. Last season, the Phoenix Suns spent the most money, $228 million, and anything above that would make the team essentially impossible to maintain. So I'll use that as my spending ceiling from now on. To fix the minutes problem, I'll make the program pick the highest VORP player at each position as a starter and give them more than 30 minutes of playing time. Then we split the remaining minutes across the rest of the players so that the whole team plays a total of 240 minutes. With all this set, it's time to run the linear program and find the truly optimal basketball team. For our starting five, we have Nikola Jokic, Giannis Antetokounmpo, Shai Gilgeous-Alexander, Amen Thompson, and Josh Hart. And on the bench we have Şengün, Cunningham, Mobley, Williams, Pritchard, Duren, and Franz Wagner. With their adjusted minutes per game, this team has a total VORP of 43.5. Plugging that into our formula outputs 132. Yes, this team is expected to win 132 games out of the 82 available ones. It literally breaks basketball. If you can figure out any improvements to this team, leave them in the comment section. But why should we stop there? Why don't we collect the data from every single player and every single season in the history of basketball to create the all-time perfect team? Well, the furthest back we can go is 1985, the year that the salary cap was introduced. Anything older than that, and we cannot apply the salary constraints, and basketball in general was way too different back then to be realistic. So I collected the data on all 4,000 players that have played in the NBA since 1985 from basketballreference.com, and I also found the salary cap from each season so that I can scale the players' salaries accordingly. See, Michael Jordan earned roughly $30 million in 1997, but this will be the same as a player earning $175 million today. So from now on, we'll use the percentage of the salary cap instead of the dollar amount. I'll also let multiple seasons of the same player enter the pool, but the solver can only pick one season per player in the final roster. So after accounting for all that and cutting out all the dominated players, we are left with 188 candidates for the all-time perfect basketball team, but only 12 can make it. For the starting five: Michael Jordan, LeBron James, Chris Paul, Charles Barkley, and David Robinson. And on the bench we have Nikola Jokic, Magic Johnson, John Stockton, Vince Carter, Andrei Kirilenko, Clyde Drexler, and Giannis Antetokounmpo. What a lineup. This team has a total VORP of 64, which gives it an expected win total of 188. As promised, I'll compare this to the 2024 US Olympics roster, arguably the greatest basketball team ever actually assembled, and their total VORP is 48.6. Almost 16 VORP less than our team, despite costing almost twice as much. If you're wondering how my program manages to get such great results while staying cheaper than the 2025 Phoenix Suns, it's mostly by taking advantage of all-time great players in their early seasons, right as they were entering their prime but before they signed massive contracts. This means we can fit a ton of valuable players that contribute to winning basketball games while staying within the budget. Thanks a lot for watching this video. If you enjoyed it, consider liking it and subscribing to the channel. I'll upload all the results and data I collected onto my Patreon if you want to take a look for yourself. You'll also get to watch new uploads early, participate in viewer polls, and get behind-the-scenes updates. So if you want to support my channel, subscribing on Patreon is the best option. The next video in the Plan Generation series is taking a bit longer than expected, which is why I wanted to get this simpler video out in the meantime. But don't worry, the video is coming in 2025. Hopefully.